Yes, students, now we are going to see about the unit 4. The unit 4 is entitled General Principles in Simulation Software. We are going to see some more general principles or many principles which are applied to the simulation, and also we are going to see the simulation software used. So, the development of a common framework for modeling of complex systems by using discrete event simulation is discussed here. So we are going to see a common framework for modeling some complex systems. So we can have some building blocks. Here we are going to use discrete events. It means that the events which occur at a specified time, and they have some length at a fixed time. After some more time duration, they will change. Sometimes they don't change, other time they change. So the basic building blocks for discrete event simulation are entities. So a simulation event simulation, a discrete event simulation has some more building blocks, which are entities, attributes, activities, and events. So it means that if I say entities, for example, people, customer, and server; attributes, customer name, customer age; activities, activities, for example, we can say, for example, deleting a customer or arrival; events. So activity and events are almost the same, but there are some differences. So activities, these are the tasks which are performed by entities. So a system will be modeled in terms of states at each point in time. The system state changes over time. So the state is not the same for all overall simulation time. So it will change time to time, and also entities will pass through the system. Entities pass through the system, and the entities represent the system resources, because these are the main characters or the main building block of the simulation. Then activities and event cause the system to change. It means that when a new customer comes, that is an event. So when a new customer comes, the total number of customers change, it increases. So the system state also change. This discrete event model appropriate for system in which system state changes only at a discrete point of time. Means that discrete events are used, models are used to model discrete system whose state changes only at a discrete point of time. It means at any specified time during the simulation time. So we can have some of the concepts. What are the concepts here? We have a system. A system will be a collection of entities like people, machines, that interact together over time to accomplish one or more goals. It means that we say that a system is a collection of entities. For example, we are talking about the bank. The bank itself will be used by people. So they will be customer and servers. They may be also other things like machines and so on. So a system is a collection of entities. Model will be an abstract representation. Abstract means that is not real. It means that we can represent a system on sheet of paper or on a computer. So it is an abstract. So it contains the structural logical. It shows the structure or logical or mathematical relationship that describe a system in terms of states, entities, and the attributes, sets, processes, events, activities, and delays. So here a model will be a representation. We represent a real system on sheets of paper, on a computer. So we are going to show its structure, the component, and the logical relationship between the element of the system. And the entity must have also attributes or the activities or processes and events occurring inside the system. So system state is what? It is a state of the system at any point of time. It means that it is the collection of variable data contain or information necessary to describe the system at any time. It means that the system state changes time to time. It means that when we are 9:30, the system has 20 customers. At 10 o'clock, the system, the bank is having 20 customers. So it means that this is the state of what? Of the bank. So the bank is what? Is the system. The system state means the number of the customer who are being served in the bank, who are there or who are in the queue. So entity is what? Entity will be an object or component in the system that requires explicit representation in the model, like a server, customer, and machine. So this is an object or component, which is the main. If the system in a system there is no entity, it means that the system is meaningless. So in order the system to be meaningful, there must be entities. Entities are many components of a system. For example, you can have a server, customer in a bank, or have a machine in a manufacturing company. So the object must be described using the entities must be described using attributes. Attributes is what is a property or characteristics of an entity. For example, waiting customer. This is an attribute because it shows the property of the customer who is waiting. Or you can say the routing of a job through a job shop. These are attributes. You can say also customer name, customer age, and so on. A list will be a collection of associated entities ordered in some logical fashion, such as our customer currently in waiting line, ordered by first come, first served, and by priority. Here we can have a list will be a list collection or a list of different entities. You can have a list of customer waiting in a queue. So a list will be called will be called that collection of customer waiting in a line. The events, it means that it is an occurrence that changes the state of the system as an arrival of a new customer. An event means that it is an occurrence which will change the state. If the new customer comes, the system will change, the queue will increase, and the system state also changes. Event notice, it means that a record of an event to occur at the current or some future time, along with any associated data necessary to execute the event. At minimum, the record includes the event type and the event time. Event notice, it is a record which shows the event which is currently occurring or the event which is about to come. So it must include two things. The first one, it must show the event type and also the time at which the event will occur. Event list means that is a list of or events which are currently in the system. It means that the event which are occurring now and the future one. So it is a list of event notice for future event ordered by time of occurrence or also in the future event list. This is a list of events which are about to come. So we call it future event list or FEL. Activity is what? It is the duration of time of specified length. It means that activity, it is a duration of time of specified length which shows the task being performed at that time. So For example, a service time, this is an activity of what? Activity of server. Arrival time, this is an activity of what? Of the customer coming. So you will know activity when at the time when it begins occurring. A delay means that a duration of time of unspecified and defined and definite length, which is known until it ends. A delay means that it is a time, but a time which is known, it is not known, but it will be known at the end. So it means a delay. It means that it is a time when you will spend. It means it is a prolongation of what, of time. So you should finish something in a time, but there may be some more activity which we prevent you from accomplishing your task. So the duration of that time of prohibition will be called the delay. So the delay is known at the end of it, because you can think that the delay it will take such time, but truly it can take any specified and specified time. So a clock, it is what? It is a variable representing simulated time. Clock, it means that it is a variable which will show a simulated time, so it is called a clock. Example, we are going to see the example of Able Baker call center, which with two servers, Able and Baker. A discrete event model has different components. We can have a system states. Here we are having a call center of where we are having two servers. The first server is Able, the second one is Baker. So if we think about that, we can say that the discrete event model of such a system we have the following components. We can have LQT, system state. We can have system state. The system state will be shown by the value of the queue, the number of colors and the time taken by the both servers and the activities. So system state first is LQT. LQT means that this is the we wrote LQT that to talk about the number of colors waiting to be served at the time T. There are some people that are calling. So the number of colors who are waiting to be served, because someone is talking to the two servers, we call it LQT. LQT means that it is a queue, the length of queue at time T. LA, it means that it means it will take a value 0 or 1, which will indicate Able is idle or busy at time T. LA will show that Able is idle or busy at time T. LB will take the value 0 or 1 to indicate that Baker is idle or busy at time T. This is the time which shows that these people are busy. So in TTZ, neither the caller nor the server need to be explicitly represented. So except in terms of state variableness, certain caller average as RZ. Here we no need to talk about the callers or servers, because callers we don't know there are too many. They can be of any length for any number, so no problem. What will be the event? The event will be arrival events. Arrival events of what? The calls. There can be also the event which is the compression, service compression by Able. It means that when Able finishes giving service to customer, So this is event. Or service compression of Baker. You can also say that the event, anything which occurs at any specified time. You can talk also about entities. Activities. Activities will be inter-arrival time. This is an activity. Or service time of Able or service time of Baker. Those are activities. What is a delay? A delay means that it is the time which will be taken by customers to wait until Able or Baker become free. Because they can talk to two people simultaneously, so you have to wait until the server becomes free. So the time of waiting will be called delay. So the event scheduling and time advance algorithm, you can have some event scheduling. You can call it event scheduling or time advance algorithms. These are algorithms which are used to advance the time for the system. So or to advance the time of the simulation. Otherwise, if this algorithm is not there, it means that the simulation will not progress. So the mechanism of the advancing simulation time and guaranteeing that or events occur in a correct chronological order is based on a future event list. So to do so, we have to have two things. We have to make sure that the events will occur in a correct chronological order, but which is based on a future event list. It means that to order the events which are about to occur, we have to have a future event list. It means a list of events which are about to occur. So there is a list, the VER will contain or event notice for events that have been scheduled to occur at future time. This will contain a list of events who are about to come. So it will contain or notices which we provide information about the events who are about to come. So at any given time t, the VER will contain or previously scheduled the future events and the associated event time T1, T2, T3. It means that VA will contain the future events which are about to come. So, and it will specify the time at which those events will come. The event one will occur at time T1, the second T2, the third T3. So the event in VA will be arranged in the chronological order. We must follow a very nice order, otherwise there will be some mistakes. See? So T must be less than T1 and T2 less or equal to T2 and so on. So it means that the event must be between T and Tn. Let's see for an example here how to represent a VER or future event to come. I'm having a clock T. This clock T is used to schedule the time duration of the simulation. I can say that the system state can be X, Y, and Z and so on. It means the system state X, we are having, for example, 10 customer. At the system state Y, I am having 15 customer like that. So I can have also entities and the attributes. I can have this one. System state X, Y, and Z. Entities and the attributes, they are not there. Set 1, set 2, not there. Future event list is here. I am having an event of type 3 which will occur at time T1. That means that it must have VER must have event type and the time at which the event will start. Here means event type 1 which will occur at time 2. this is the future event list will have such type of information. So here after that you will have a cumulative statistics and counters which are used to count and provide the report of what you got. So the time t is the current value here. This one is the current value of simulated time now. So it is the value of clock variable. So the event associated for the time t1 is the next event that will occur and is called the imminent event. The next event after time t will be at t1. This will be called imminent event. It means that the next event which is about to come. After that, after the system snapshot at clock is equal to t, if we update it, it means that we have the time of t1. Then the clock will be moved to clock is called t1. So it means that t the event at time of t has finished. So we are going to increase or to increment the time so that we go to the next event. And the imminent event is noticed, and the imminent event notice is removed from the VEL. So that there was an event notice which was providing information of the event T1 which was about to come. So as now we are on T1, its event notice has been to be removed from VEL. So the execution of imminent event means that the new system is now short for the time of T1 is created. It means that when you start executing the system at the time of T1, it means that the snapshot of the system at T1 is created. So the sequence of action that the simulator must perform to advance the clock and build the new system snapshot will be called event scheduling time or advanced algorithm. It means that advanced algorithm or event scheduling time algorithm is what? It is an algorithm which is going to help to do the sequence of action so that we advance the clock and build the new snapshot. It means that the algorithm, the advanced algorithm is an algorithm which is going to help us to schedule tasks in our simulation time. Otherwise, if this algorithm is not there, it means that there won't be any scheduling inside the simulation. So the step, we are going to see the step of this algorithm are, we are going to see the step, what are the steps of advanced algorithm. I am having all the system snapshot at time t. At time t, we are having a system snapshot. It means that the state of the system at time t. So this is the old system snapshot. So at time t, we are having a clock, the variable t, which represents the clock to advance the system simulation. So we're having 5, 1, 6. This is the system state. At time t, we're having 3 states. The system was at 3 states, at 5, 1, and 6. So future event is at this time we're having type 3 event which had to occur at time t1, and type 1 event to occur at time 2. The same type 1 event to occur at time 3, and so on. So this is the time advance event scheduling or time advance algorithm. So it is here how to perform this algorithm. We remove the event notice for the imminent event, event 3 time t1. We have to remove the event notice for event which is about to come. The next event is this one. So I have to remove the event notice for this event. I remove it from VEL. Step 2, after removing it, I advance the clock to imminent event. So I advance the clock from T to T1 here. From T to T1. Step 3, I execute the imminent event. I execute it. After executing it, I update the system because some new task or some new events or some change will provide the system. And we have to change entity attributes and set membership as needed. It means that from first step, I remove the event notice. The second one, I advance the clock to T1 and then execute the event. After that, I have to generate the future event. It means that a list of events which will become next, which will be coming next. And after generating them, I have to also to generate the notice of both of those events. But those events will be ranked by event time. It means that it will depend on the time at which they will occur. For example, here I order this one because this will be fast because it will occur at T1, this T2, this T3, like that. So maybe the next event will be type 2 event which will occur at T4, like that. So here it means that event 4 must occur at T star. T star means it can be between T2 and T3, no problem. After that, after generating, doing everything, I have to update the cumulative statistic and the counters. It means that I have to update the what? I provided the report, the statistics, and the counters. It means that because I have to increment the counters, so I have to update the counters and give them an updated value. So the new system is now shot at T1. At T1, the new system has changed. It means that at T1 I am having 515. It means that the state of the system has been changed. So here I am going to have a type 1 event occur at T2 and the time 4 event which will occur at time T star, so the time which we don't know yet, and so on. Now we are going to say about the word view. When using simulation package, the modeler adopts a word view or orientation of developing a model. When you are developing a model, you have to provide an orientation. So, an orientation means that it is how the word will view or will see your system. How? We can have an event scheduling word view. Event scheduling word view. Event scheduling word view means that here a simulation analyst will concentrate on events and the effect on the system. Here, when we have event scheduling word view, the analyst will concentrate on events, only on events and the effect on the system. It means that if such event will occur, what will be the effect of such activity? You will also think about the process integration word view. The process means that integration word view, interaction between entities within the system. So the analyst define the simulation model in terms of entities. You think about entities or object and life cycle as they flow through the system, demanding resources and queuing to wait for resources. Here we think about entities and they flow inside the system. When they're flowing, they will demand some resources or queuing to wait for resources. So a process is the life cycle of one entity. A process will be life cycle of one entity. That one customer is there in your company, he's getting services. The time he will spend inside your system will be the life cycle of such customer. This is called process. So it means that the life cycle or process consists of the events, the arrival event of the customer, and the activities that what you have done in your system. You can have also activity. Activity can be scanning word view. Scanning means that This uses a fixed time increment in the rule. This is the approach to decide whether an activity can begin at the each point in simulated time. The activity scanning approach is later modified to involve certain advantage of event scheduling approach. Now, it allows variable time advance and avoidance scanning when it is not necessary. This is called a three-phase approach of activity scanning. Activity scanning, it means that we scan, it means that we have a fixed time increment and lower. It means that we have to know when the activity has begun at each point in simulated time. So the activity scanning, it means that you continue checking the activities who are occurring inside the system, and then you see that so B activities, these are activities which are bound to occur. These are activities which are about to occur. It means that our primary events, the conditional events, conditional activities fall into this category. It means that B activities, these are activities which are about to occur. So these activities, these type of activities will define primary and conditional. So primary events, these are many events. Conditional activities are activities which will occur according to condition. If some conditions are met, so it means that these activities will occur. See, these activities are activities or events that may happen only upon a certain condition. So say activities are activities which will happen if a condition happens. So with three-phase approach, the simulation is carried out with repeated execution till it is completed as below. We can have phase A. Phase A, we remove the imminent event from VEL. We remove the event which is about to occur. We remove it from VEL, and then after removing it, we advance the clock to its event time, and then we remove any other event which has the same time. So it means that at phase A, we remove any event which is about to come. At B, we execute or B type events which have been removed previously from VEL. At C, we scan the condition that trigger each C type activity and activate any other activity whose conditions are met. We have to scan until there is no additional C type activities can begin and no event to occur. So we can have manual simulation using event scheduling. You can have manual simulation using event scheduling. Here we have an example of the manual simulation. Here a simulation table is used. Here we have a simulation table which will be used to record or successive system snapshot at times as times passes. So we are going to have a simulation table which will record the succession of the system snapshots as times passes. For example, let's see the example we saw in chapter 3 of a single server queuing example. So the system it contains the customer who are waiting in a queue and another customer who is getting service. So we're having two customers. The one is one is in a queue. The second one is in the service at the counter. So a stopping time, we have to stop the simulation after 6 minutes. So we can have an interarrival and service time distribution are given below. So these are the value are the same as the one which have been provided in chapter 3. So they are almost the same. So we are having the distribution here or here. Service time, the range between 1 minute and 6 minutes. It means that service time will be ranging between 1 and 6 minutes. So when we have a service time of 1 minute, the probability of getting the service in 1 minute will be 0.1. Here the probability to have service in 6 minutes, the probability is 0.05. So the random number of enter arrival, it is the same as in the example or in chapter 3. It is for the random number of enter arrival, the enter arrival between the first customer and the second customer, it is 913. The enter arrival of the last customer and the previous one is 302. The service time for the last customer will be the 3080. So we can compute the enter arrival and service time as given in unit 3. So if you want to see the computation for enter arrival and service time is the same as we did in the example of the unit 3. It is the same. So you can check on this page number 58 to 60. So our model will have the following components. There will be LQT. This is the number of customers in the waiting line. It means the number of customers who are in the queue. LAST will be the number of the customer who is being served. It can be 0 or 1 at time t. So entities will be servers and customers, but they are not modeled here explicitly because here we have state variable no need. So the events, they will be arrival event A, it will be denoted by A, departure will be denoted by D, stopping event will be E. It will be scheduled to occur at time 16. It means when the simulation ends. So event notice, the event notice AT represent that arrival event A will occur at time t. This is a notation. This notation represents that a customer has the customer departure in the future time t. Here it will be present the simulation at the time at which the simulation will stop. It will stop at after 60 minutes. If activities, it means that enter arrival time, if it means the enter arrival time, which will be defined in the time service. There will be also the delay. It means that it is the time the customer will be wasting when they will spend it in the queue. The event notice are written as ordered pair. The event notice are represented in ordered pair. It means using two symbols. Event type, they will be event type and event time. The type of event and the time at which that event will occur. In this model, VER always contain 2-3 events noticed. It has to have 3 event noticed to provide information about the event which is about to occur. The effect of arrival and departure event are shown in. It means that when the customer arrives into the queue and one is gone, there will be an effect to the system. How? So you have an arrival of a new customer. So arrival event occur at clock t. arrival of the customer. For example, the customer John comes to your bank at time T at 9:30, for example. So we will ask ourselves a question: is LST equal to 1? LST means that is there at the service counter? Is there anyone being served? If yes, we will increase LQT by 1. It means that if there is someone at the counter, so the new customer arriving can't go immediately to the counter. It has to go into the queue. That is why we will increase the queue. The number of people in the queue we will add 1. So the new customer will enter the queue. So he will be waiting. If you know, it means that if there is no one at the counter, it means that this man immediately will go to the service. So LS will be equal to 1. There is he will be 1 customer there. So in this case, if he enters into the queue, we have to check here. We have to generate inter arrival time A star and schedule next arrival event time T plus A star. So we have to generate inter arrival. We have to think about another person who will come, but he will come at time at an unknown time, so we don't know it. So we have to schedule the event, the next arrival at event T. So we are at T and we plus A star because we don't know the time at which the second customer will come. So if here he goes to this man goes to the counter, he's getting service. We generate the service time, the service time, the time he will spend at the service counter, and we have to schedule his departure. After getting service, he will go event. So this event will occur at a time of T plus S. The S is the time we don't know. So after that, what I have to do? I have to collect statistics. Collect statistics. It means that I am going to generate statistics, the results, the probabilities in the results, and then provide the report. After that, we return the control to the time advance routine to continue simulation. It means that if we finish this turn, this round, it means that I have to increase the simulation time to simulate the next event. What about the arrival? Wait, no, the arrival, we finished the arrival. What about the departure? The departure event. The departure event will occur at the clock at time T, when the clock is equal to T. So when someone has been served, so he's going out, so we have to ask ourselves a question: is LQT greater than 0? It means that is some people in the queue? If it is greater than 0, it means that some people are in the queue. If it is yes, we reduce the LQ by 1. It means that we take the person who is at the top, we take him to the service counter, so the people remaining in the queue will be reduced by 1. After that, we will generate the service time S. We generate the service time. It means that the duration, the server will give the customer the service. We don't know it yet. That is why we put S star. After that, we have to schedule the departure of that person at the time plus S star. It means that at this time plus the service time we don't know. If not, it means that we are having the queue. In the queue there is nobody. If there is nobody, it means that LS is equal to 0. It means that nobody is in the queue. It means that LS, there is nobody. If there is nobody, it means there is no service to anybody. That is why it will be equal to 0. After that, we have to collect also the statistics. It means that we have to record the results we obtained, and then we have to provide the reports. After that, we have to return the control time advance routine. We have to continue simulating the next event. So that is why we have to step to the next process. So So with the help of given random number and the probability distribution table, the inter-arrival time and the service time of the customer have been computed as in below. So it is what we got previously. Here we are having inter-arrival and the service time. It is the same. It is the same as in the example of unit 3. Let's check. It means that here what happened, I am having customer, I am having a 10 customer. It is the same example. This value have been provided in the example of a single server in chapter 3. Inter-arrival also have been provided. Arrival time in the clock, you have to have accumulation, the accumulation of this one. So I have 0. This is 0. I take it here. Then I take 0 plus 8. It means 0 plus 8. It will be 8. 8 plus 6, 14. 14 plus 1, 15, like that. Service time has been given also. Then after that, the simulation table for checkout counter is shown in table, and in table 5.3 it is generated as explained below. Here I am having the table, the simulation table. So the simulation table is this one. Let's check the one which is visible. I see that this is not a very visible, so we can take another one. So let's check if this one is visible. Okay, this is visible. Okay, so let's check here. The simulation table will be like this. The simulation table will be like this. First customer will arrive at time 0. The first customer arrives at time 0. Because this customer is the first one, immediately he will go to the counter, to the service counter. So he will start getting service. So the number of customer waiting in the line, LQT, is 0 because no customer is there in the line, in the queue. So it is still 0. And the number of people being served, it is 1. Why? Because that new customer has come. So he is only 1. So he is at the service counter. So it will be LST is equal to 1. We have to note that the second customer will arrive at time 80. If he comes at time 80, and the service time for the first customer is 4. So it means that the first customer will last for 4 minutes at the counter, service counter. So the server and the second customer will come after 80 minutes. It means that the counter will be idle for 4 minutes. So the first departure will occur first, and then the next arrival of event second customer will occur. So we have to indicate this in VER. So the simulation table, we can see what we talked about. The first customer at the clock 0, system state is in the queue. There is nobody. It is 0. But in the service there is 1 person, the first customer. So the departure will occur after 4 minutes. The arrival of the second customer will occur after 80 minutes. So the event will stop, or the simulation will stop after 60 minutes. This is the meaning. Yeah. So cumulative statistics, there is nothing here. And we can go to the next day. We can have here it should be 2. The notation A star, it is arrival time. S star is also the service time. Okay, it is understandable. And server BC is denoted by B. The maximum queue length is denoted by MQ. The server busy. The server busy here, you can say the server busy, it is not busy here because we are at the starting point. In the queue, also the maximum queue length, there is nobody because it is 0. So arrival and departure are noted in the clock, and according LQT and LST are written in the table. Arrival and departure are noted in the clock. So the common account will give the explanation about the arrival and departure event as long as the respective time A star, S star, B and M, Q start are computed accordingly. We have to compute them. So you can interpret this one as I am interpreting it. You know, it means that at the clock 4, in the queue, nobody is there. Nobody is buying a service because the second customer will come after 8 minutes. And then here we are having a arrival will come after 80 minutes. And the destination will stop at 60 time. The first departure occurs after 4 minutes. So B will be equal to 4. At 80, in the queue there is nobody, but in the service it will be 1 because there is no one in the queue. So after 80 minutes, only one person will be at the service. So we will go after 9 minutes here, and the next arrival will come after 14 minutes, and so on. You can interpret all the table like this. Okay, it is very good. So after that, when we are talking about the queues, we can also talk about the list processing. It means that when we are having a customer in the queue, it means that we are talking about the list of customer in the queue. So you have to order those customer into the queue so that your scheduling will follow an ordered list. So list processing deals with the method of handling list of entities in the futures event list. List processing, we have processed list of entities and the occurring events. So simulation packages will provide the facilities for an analyst to use a list and to perform basic operational list. So for analyst, we have opportunities to provide or to make some lists and provide some basic operation on those lists. So what are basic properties in operation performed on the list? What are the properties in the operation? So lists are a set of ordered or ranked records. It is a list of records. So in a simulation, each records will represent one entity. If you are having 100 customer, I am having a list of 100 customers. So each record is an information of one entity or information about the one customer. So it means that this means that it is almost the same as in the database. So we can have a list of customer stored in the database. So one record will provide information about one customer or one student, for example. At the top or head, we are having the first item on the list. The first customer will go at the top. There may be some way to traverse the list. We can have some way to navigate inside the list. So we can have also a bottom or tray. A bottom means the last item, the last customer. The 100th customer will be at the bottom or tray. So every record in the list will have the field. Every record means that each customer will have a customer name, customer account number, address, and so on, like that. So every record in this has a field like identifier. These are used to identify each entity, and it will have attributes also a pointer which is used to refer to the next record in the list. It means that there must be a pointer which shows the next record to be processed after in the list. So you can have some list which points which have pointers pointing to the next record, or I can have a list having a pointer referring to the previous record. So this can be doubly linked list as in programming language C, C++, and so on. What is the operation which are performed on lists? You can remove a record from the top of the list. It means that I remove the first record, no problem. Or I can remove a record of any location, anyone inside the list, or in the middle of the list, or I can add the record at the top or the bottom. Anyway, you can do anything. So, in the event scheduling approach, when the time is advanced and the imminent event is due to be executed, the removal operation takes place. First, the event from phi air is removed. When you are having phi air which contains a list of events which are about to come, when you want to remove the event from the list, you have to first remove the first one. So, or due to some priority or any between record may be removed. According to the priority, you can remove also some record in between. So when an entity joins the queue, first in, first out, first in, first out, addition is done at the end of the queue. If the queue has the earliest due date first, then the addition may be at any position. So when I have a first in, first out, when the new customer joins the queue, it means that the addition will be done at the end of the queue, so that when I'm going to remove, I remove the one who is in the top. It means that the first who came, the one who came first has to be removed the first. So that the new one has to be at the end. If I use this technique, earliest due date first, so you can add it at any position in the list. So for simulation on a computer, list can be represented two ways. In a computer, for simulation, you can have arrays and linked list, like in data structure. Arrays will use a contiguous memory allocation in the hence, or records are stored contiguously in the memory. So the record can be referred as using array index, as you know in programming, to access any value at any location in the array. I have to use array index. So it will use a memory allocation or memory shortage or hostage. So here array will waste memory. Why? Because when you want to insert or delete any record in between, it means in the middle of the list, you have to shift other records. The next the previous record or the next record. So this is a memory hostage. Linked list will be used for dynamic memory allocation. It means that the simulation languages, the record are dynamically created. It means that having the list in the form of linked list with dynamic memory, it is the best option to do. So when you add, when you insert a new record, memory will be acquired without affecting the existing record. It means that you add a new record, so you will have an immediate memory which will be allocated to that new record without affecting the existing records. So it is a very good idea. So you can have also simulation in Java. Java is one of the languages which are widely used in simulation, but it doesn't provide direct facilities, because the programmer has to do what? Has to program every detail of event scheduling time advance algorithm. Statistics, gathering, everything you have to hand yourself for you have to program it. So there is no interface which has been provided in advance to simulate. So you have to program every and each details which have to be provided during the simulation. So any discrete event simulation model written in Java will have the system state. We must provide the system state, entities, the attributes, sets, events, activities, delays, and so on. So there will be different components. The first one is a clock. A clock will be a variable. A clock is used to advance or schedule the events inside our system. There will be also initialization method. This is a method, a function which will define the system state at time 0. So this is the initialization method that will provide the state of the system at the beginning. So the mean time event method, this is the second method, will be a method which will provide the information about the imminent event. The imminent event is the event which is about to come. So it is a record in the field that has a small time stamped, means it will be the next one to come. There will be also event method. This for each event type, a method to update the system state and cumulative statistics when the event occurs. This will be used when the event occurs. So it will be used to update the system because a new event is occurring. It means that the system state has changed. The random variety generator means this is a method which generates samples from the probability distribution. This will generate random variables. The main program is what? It will be the main function which will call other function in order to execute specified task. So to maintain a control of event scheduling, this will be like the controller to provide to schedule the execution of the program. There will be another method to provide to generate a report. The method that computes summary statistics from cumulative statistics and print a report at the end of simulation. After running the simulation, there will be a function which we compute the summary of statistics, or for example the probabilities, and then after accumulating the results, it will print the report and save it, for example, inside the file so that you can interpret the results. So we can have the structure for event scheduling the simulation program in Java. How? Using this program. There will be the main program. So the main program will start the simulation obtaining input from parameters. Here, the main program will start first the program, the simulation. At the beginning, it has collected the input parameter. They can collect the time, the events, they can collect everything. After that, it will call the subroutine. To call the subroutine means that we have to set the clock at 0. Then it means that we have to initialize our variable here. So they have to start at 0 because nothing happened yet. So we set cumulative statistics to 0 also. We generate initial events and the press on VER. Here we generate the events which we are planning to occur at the first time, and then we have to store them in VER, and then we define the initial system state. After that, the main program has to call the time advance subroutine. Time advance subroutine contains a method which are used to advance the time from T to T1. So after advancing, what this function will do? What it will do? Time advance subroutine means it will find the imminent event, say I. It will find the event which is about to occur, and then it will advance the clock from to the imminent event. Means that it will find the imminent event, it means the event which is about to come, and then they advance the clock from T to T1, and then after After executing this task, it will return the result here, to return to the main function. So the main program will call the appropriate event subroutine. After this has finished its task, so it returns the result to the main program, and the main program will call another subroutine to execute some processes and return the results. After that, the main program will ask itself, simulation is the simulation over or not? If the simulation is over, it means that we report generate. It means we will compute summary statistics. It means the result we have obtained, and then we print report. Otherwise, the main program will continue calling different subroutine, which are used to advance the program, the simulation. So every time what event subroutine will do every time, it will execute event I. After executing the event I, it will update the system state. Then it will update the entity attributes, set membership. After that, it will correct the results, and then it will generate the future event list in air. So after that, after doing this, it will return to the main. It will ask. It will come here, and then the main program will ask itself if the simulation is over or not. If it is over, we stop. If not, we continue until or events have been scheduled. Okay, dear students. So now we have finished the unit 4. So next time we are going to see input modeling, which is a very interesting unit. So you have to follow it very carefully. So you read it very carefully and follow my explanation. If you have any question, you have to ask me. Thank you.